Hello guys and welcome again to a new video. Now we are in the second assignment on decision tree. Previously we have covered classification tree. Now in this assignment we will be covering regression tree. So let's start with the part A of our question 1, which says for the German credit dataset, build a regression tree using amount as the dependent variable and the other variables as the independent variables. So first we will read the data as usual using the read.csv function, and then store it in the variable German underscore credit. Then as usual, we will check the missing values. As I explained earlier, these are the repetitive steps. We have used German credit dataset in many assignments, and we always start with these steps: checking the structure of the data, summarizing the data, checking for the missing values, outliers, etc. These steps are for preparing the data for further analysis. So I'll not be showing all these steps because we have already seen these steps in different assignments. Hence, I will straight away move ahead and build a regression tree. So for building the regression tree, we will have to load the library which has the tree function. So we will load the tree library as shown here, and then we will use the tree function. So the first argument will be amount, which is our dependent variable, then a tilde sign followed by a dot, which means we are including all the variables. Then the second argument is the data, which is stored in the German underscore credit variable. We will run this and store our model in the variable German underscore reg. Then the next part says use the summary function to view the diagnostics and explain the results. So we will run the summary for our model, and here as you can see the results are printed. A small explanation is also included here, so we will refer to it. Point 1 says there are 13 nodes in the tree. Then point 2 says the important variables used in building the tree are only 6 out of 62. Then point 3 says residual mean deviance is 3532000, which is very high. And here deviance actually means the squared error. Even if we calculate the root mean square error by taking the root of this number, it will come somewhere around 1879, which is still a high number. Anyways, right now it does not matter because we are doing this to understand the process. So we will move to the next part, which says use CV to find the best split. So we will use cv.tree function and give our model as the first argument, and then run this and store it in the variable cv underscore German. After this, we will use the plot function as shown here. Now you can see from the above plot that the minimum CV error is for the 9 variable model. However, if we analyze the graph further, then we can see that there is a marginal decrease in error between 7 to 9. And for the sake of simplicity, we will take 7 nodes tree as our best tree. Now we will move to the next part, which says prune the tree and plot it. And then it further asks, do you like the tree or not? Give reasons for your answer. So we will use prune.tree function as shown here and store it in the variable prune underscore reg. After this, we will summarize our prune tree. Now we can read the explanation of the summary given here. It says the initial tree had 13 nodes, and post pruning the tree, now it only has 9 nodes. And thus our interpretability has increased. However, any conclusion about the performance can only be arrived once it is validated through train and test approach, because residual mean deviance is still very high. Now we can use the plot function to plot the prune tree. First argument is the prune tree. Second argument is the title of the plot. Then we will use the text function to name the nodes. and then we can run this and our plot is shown here. Now this plot is easy to interpret and we have already seen this earlier, so I will not explain it again. Now next question says, can you interpret the interactions in the tree? Now we already know that the child nodes are nothing but interactions in the tree. So by looking at the tree above, we can deduce the interactions. We have already seen this in the previous assignment, so I will not be explaining it again. You can pause the screen and you can read through the explanation if you want to. So this is how we build a regression tree. Now let's move on to the second question. In this question, we will split the data into training and test part, then perform all these steps for the training part, and then predict the data in the test sample. This way we will be able to find out how the model is performing on the test data. So let's start with step 1 and create the train and test split and then build the model. So we will set the seed first. After this, let's first create a variable named as sample. We will use sample function here. Give our first argument as the number of rows of a German credit dataset. Then we will mention the sample size as 70% of the total rows and then run it. Then we can create this to create our training data by subsetting German underscore credit dataset using sample variable and store it in the variable train. This means 70% of the observations will be subsetted. Similarly, we can create the test data using the sample variable, but we will just mention a minus sign before it so that it will exclude those values which are there in the training variable. So that is how we have created a train and test split. In previous assignments, we have seen different ways of creating this split. You can use either of the methods, or you can come up with your own as well. The basic idea is to bring more and more randomness in the samples. After this, we will build the model. So we will use tree function again. And this time we will use the training dataset, which is stored in the variable train. We will run this and store the model in the variable German underscore train. After this, we can check the summary of our model using the summary function. So the summary is printed here. We can refer to the explanation given here. It says from the above summary, we can deduce that 7 variables are used for building the tree with 17 terminal nodes. Number of terminal nodes in the tree is 13 and residual mean deviance is equal to 3479000. Now moving to the next step, use cross-validation to find the best split. So we will use cv.tree function as shown here. Store the results in the variable cv underscore German underscore tree and then we will plot it. Now from the above plot we can see that the minimum CV error is for 9 variable model. However, if we analyze the graph, then we can see that there is a marginal decrease in error between 7 to 9. And for simplicity's sake, we will take 7 nodes tree as our best tree. Now again the explanation is given here. After this we'll move to step 3. In step 3 we will prune the tree and then plot it. So we will use prune function and then give 7 nodes as shown here. We will store the results in the variable prune underscore German underscore tree and then we can simply plot it using the plot function. And again we are using the text function to name the nodes. We will run this and we can see our tree is printed here. Now the last step is to make the prediction using the test data and assess the accuracy of the model. So we will use predict command First argument would be the prune tree stored in the variable prune underscore German underscore tree. And second argument would be the test data, which is stored in the variable test. We will run this and store the results in the variable predict underscore test. After this, we will calculate the error using mean squared error. Mean squared error is equal to the predicted values, which are stored in predict underscore test, minus the amount which is stored in the test data. We can get it by subsetting it using the dollar sign, and then square it and then take the average of it. This will give us the mean squared error, and then we'll store it in the variable error. We can also take the square root of it to calculate root mean squared error and store it in the variable r error. Now again the explanation is given here. So let's read the explanation which is given here. As we know that the smaller the mean squared error, the closer the fit is to the data. Now the MSE has the units squared. So we take root and find out RMSE, which is directly interpretable in terms of measurement units and is a better measure of goodness of fit. Now root MSE means that we can conclude that the amount will vary by 2039.51 from the true median amount, which is a huge variation, and hence our tree cannot be considered good model. Third point says, from the above results we can see that the error is increased substantially from the training data and hence it is not acceptable. So we will try pruning the tree again using the minimum CV error, that is 9 nodes, and check if the result improves. So let's go to step 5 and prune the tree using 9 nodes. We will use the prune.tree function again, and this time we will give best is equal to 9. Then we will store the results in the variable prune underscore German underscore tree 2. After this, we will use this to make the prediction again. We will use the predict function as we did above and store the results in the variable predict underscore test 2. Then we'll find the mean squared error and store it in the variable error 2. And the root mean squared error, we will store it in the variable r error 2. Now if we see the results, we can see that the error has not reduced by going from 7 nodal tree to 9 nodal tree. We can see there is still a huge difference between the training and test error. Also, if we look at RMSE, we can conclude that the amount will vary by 2041 from the true median amount, which is again a huge variation. And hence, this tree as well cannot be considered a good model. Okay, so that will be all from this assignment, guys. In this assignment, we have seen that the model that we have built on training data did not perform very well on the test data, and hence we need to do some course correction. Now, how can we improve this model by tweaking different parameters? That's a different topic altogether. And right now, that is not our learning aim. My intention here was to show you how regression tree is generated. What are the steps involved in it? And as far as the troubleshooting is concerned, to make our model better by altering different parameters or cleaning the data, that can be done later on. But I hope you have got a fairly good idea about the entire process. So we have learned regression tree in this assignment, interpreted the summary, interpreted interactions, made a tree plot, then built the regression tree on training data, and then made the prediction using the test data. We had pruned the tree by using 2 different nodal values to see if any improvements can be done, but we could not improve the results. And hence in the conclusion we can say that more analysis is recommended. Okay, so that is all from this video, guys. We will meet again in the next video where we will cover more methods like bagging, random forest, etc. So until next time, see you.